End of next week, I'd like to be done. So we'll kind of play around with, how long do we want to review for? What do we need to do to make sure we've all got it? And we'll kind of wait and see what happens at the board meeting, the school board meeting on Tuesday, whether they decide we're back hybrid the following Monday, the 8th. That's kind of like the next possible date we could be back. And then we'll just kind of go from there. So, keep your options open for now, but I do want to start wrapping things up as best we can sooner rather than later. So I'm going to call this simplifying square roots. Although it works for all kinds of different roots, cube roots, fourth roots, fifth roots, it's just a little bit trickier because these aren't so bad. Now, in order to make sure you kind of believe what I'm about to do, I have to make sure you're okay with what I'm thinking. So here's kind of the background idea as to why we think this works. So hopefully this clicks for you. So do you agree, so you don't have to answer out loud, but do you agree in your head that 8 is the same thing as 4 times 2? I know there's a couple different ways to get to 8, but 4 times 2 is obviously one of those, right? And if I've got an equation that's true, as long as I do the same thing to the left and same thing to the right, it should stay balanced, right? If I added 1 to both sides, or divided by 5, or multiplied by 7, or took the square root, it should be the same, right? So if I take the square root of the left, as long as I take the square root of the right, those things should still be true. All right, so I can rewrite square roots however I want, as long as what's underneath gets me back to that number. And I can do it with adding, I can do it with multiplying, I can do it with dividing. All of that should still be true, okay? And here's the other thing that I want you to kind of believe. I'm going to go this way, but I'm just going to worry about that. We want to see if it's okay for me to break one square root into 2. And so I'm going to share my screen real quick so you can kind of believe it. Just hopefully 1 or 2 examples is enough for you to kind of say, yeah, that makes sense. It works. The numbers work out. So check this out. So the square root of 8, right? Some decimal, right? Okay, the square root of 2 plus 6. Sweet. Same number, right? Because 2 plus 6 is 8. Or 1 plus 7, right? All good. Or 4 times 2. Okay, 8 is 4 times 2, cool. So the square root of that, I get the same long crazy decimal. And obviously the square root isn't nice because we have this decimal, so I just want to figure out like a better way to write it. And so the question is, so let me show you this one first. Let me do the 2 plus 6. You're good, no worries. Okay, so check this out. Is that the same as me doing like the square root of 2 and then separately adding the square root of 6? Ugh. Nope. Like those numbers don't work, right? I can't break apart a square root using addition. Or it doesn't matter which way I do it, like 1 and 7. Okay, I still get the same thing under here because it's one big square root. But if I did the square root of 1 plus the square root of 7, right? Different numbers here to here. So that doesn't work. You can't separate them with addition. But what about multiplication? If I rewrote this as the square root of 4 times the square root of 2, look at that. Right, same decimal all the way through. And I could show you lots and lots of different examples, like square root of, I don't know, like square root of 20. Okay, well, that's 4 times 5. So does it still work? Yeah, right, same decimal. Still some long, nasty looking thing, but at least I can break it apart. Now, so here's what I'm thinking, right? If we can believe that, if things are being multiplied together, then I can break it up into the square root of 4 times the square root of 2. Look what this lets us do. Square root of 8, not nice. But it did have a really nice number that went into it nicely, right? 4 goes evenly into 8. And the square root of 4, so I'm going to work vertically so you can see how things connect right here. The square root of 4 is 2. Right? Now, obviously, the square root of 2, there's nothing I can do with that. But what I've got is a way to make the number under the square root smaller, which is nice because I don't have to deal with bigger numbers. And I've got a number on the outside now that I can start putting together with other numbers that are on the outside. Because numbers on the inside can go with numbers on the inside, right? I can multiply them together, I can break them apart. As long as they stay underneath, I'm good to go. And now, instead of having to deal with a number like 8, now I've got a nice number like 2 on the outside, and the ugliness of the inside at least got a little bit smaller. And so what we want to do, so I'm going to write a little how-to over here in case you like that, right? What I want to do first, if I'm trying to simplify square roots, first I just check the original square root. Like I plug it in my calculator, I see what I get. Okay, if it's really nice, then I'm done, right? Square root of 9, okay, 3. My square root is now simpler. Square root of 25, okay, 5, right? Because it's perfect, and I can just do it that way. But if it's not perfect, then we got to keep going. And what I want to try to do is take my square root, whatever is under here, and I kind of want to break it up into 2 separate square roots, like we did here, right? Square root of 8 became the square root of 4 times the square root of 2. And what I would love for this first one to be, I want that to be what's called a perfect square. That's a weird looking R, a perfect square. But I want it to be a perfect square that goes in evenly to the number that I was just dealing with, right? A perfect square factor of my original number. This, we're kind of stuck with whatever's left, okay? What's left? So that, call this one number 1 if you want, right? We've got the square root of 8. If I can, and now I'm going to rewrite it vertically so it's a little bit easier to see. If I can break this apart into 2 square roots, where the first number is the biggest, actually, let's say that perfect square root factor, let's make it the biggest one, the largest. The biggest perfect square factor that goes into it, like 4 goes evenly into 8. Okay, 4 times what? Well, okay, 4 times 2, right? Then I can simplify this first one, get rid of the square root, like actually take the square root of 4 and just kind of bring that one down with me. So that'll kind of be my last step. I'm going to simplify this one and bring down this one, and then I'll be done. Okay? If I can find a perfect square factor that goes in perfectly, I can break it apart by putting that first square root, the nice one, first, and then I'll just take it, right? Like this. Check this out. Like, I don't know, like the square root of, I don't know, 24. If there is a number that goes in perfectly into 24, that's also a perfect square, then I can break it apart into 2 square roots connected by multiplication, kind of skipping that step of writing it as the multiplication in between. But writing 2 separate ones, then I'll just take the square root of the first one, it's going to be perfect, and I'll just bring the second one down with me. All right, so think about it. What number goes in perfectly into 24 that's also a perfect square?
4 and 6.
Right? 4 goes in perfectly. Obviously, we're kind of stuck with 6 because 4 times 6 is what gets us back to it. And the square root of 4 is 2. right? Drop the square root, change the number because it's perfect, and then just bring that second square root down with you. That's what I'm hoping to do. Now, maybe you don't know all of your perfect squares. And so what I want to give you are the first 15. Okay, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, like that. Okay, here's a nice list of what are called perfect squares. Okay, obviously 1 squared is 1. I'm going to skip that one, but it's there, right? I don't really have to talk about that one. I'll write it down though. It is a perfect square. 2 squared is 4, 3 squared, 4 squared, 5 squared, right? So 1, 4, 9, 16, 25, because maybe you don't have these stuck in your brain, it's okay. 6 squared is 36, 7 squared, 49. If you know these, great. 8 squared, 64, 9 squared, 81, 10 squared, 100. Those are probably ones that most of us have a pretty good memory of, and maybe you don't, that's okay, but here's your list. The next 5, maybe you don't know quite as well, but they are nice to know. Okay, 11 squared, 121. 12 squared, 144. 13 squared is 169. 14 squared, actually just switch the 6 and the 9, comes at 196. And then 15 squared is 225. Okay, so this is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and on down like that. Write them all down if you think you need to. Because when I'm trying to simplify square roots, I'm only looking at these numbers, seeing if they go in perfectly to whatever my number is that's stuck underneath. Okay? And what you'll see by Monday is that if we can take those, those quadratic formula ones or the vertex form ones that have those nasty looking square roots, maybe I can at least make that number a little bit smaller, right? Because look, 24, number underneath, actually it just ended up being a 6, okay? 8, right, number underneath ended up being a 2. And then I was able to pull out some nicer numbers because then I can maybe do something with that to make my answer just simpler, okay? And so I really like it for that reason, right? My numbers get smaller, things can get simpler. And when I'm doing math, man, the smaller the numbers, the easier they are to deal with, right? At least that's kind of my hope. So there's your nice list of the first 15. You don't have to have them memorized. You got them written down maybe. Or, you can always just look them up. I want to know what 6 squared is. Okay, type in the calculator. 6 squared, 36. It's just faster if you know. And so I just want to do a couple more with you so you can see it in action. I'll give you a couple to try. You don't have to submit anything for me today, but I do want you to have these down so that tomorrow, when I do send you some practice with this, you've got some things to look back at. Okay. So I'm going to go to the other side. Go to the other board. I want to leave this up in case we have to come back to it. But let me know. Are we good? Can I move? Okay, cool. Here we go. So all we're going to do today is just make sure we can simplify square roots. All right, so call this one number 3. And what I'm looking for is a number underneath that square root so that I have something to do with, okay? Now, if I put like 36 under there, okay, 6, done. Like I don't have to do this whole break it apart kind of thing. Put 100 under there, okay, square root of 100 is 10, and I don't have to worry about breaking it apart. It's the numbers that are underneath that are not nice. Right? Plug it in the calculator, you get a not so nice answer. I want to try to do something with that. So help me out. What if it was the square root of 50? Right? Plug it in the calculator, no good. Right? It's just a little bit more than 7. Right? Because square root of 49 is 7. This is just a little bit more than that. So 7 point something. Right? Well, that's not going to work. But I can't use like 49 plus 1. This doesn't work with addition and subtraction. It can only be connected by things like multiplication and division. And we're just going to do the multiplication part. So I would love to break this apart into 2 square roots. I'm going to put the dot there for multiplication just so we remember how these numbers are going to get connected. And I always want the first one to be the nice one. Because then I can put the nice number up front, like we always do. So think about it. What number goes into 50 perfectly that's also a perfect square?
25.
25. And once we make that choice, right, the number that goes under the second square root, we're kind of stuck with whatever it is, because 25 times, well, in this case, 2, right, is what gets you to 50. So it's just kind of what's left over once you divide by that 25. Okay, now that I've got it, right, my plan is to just simplify the first one, see what I get, and then leave the second one all by itself. And when I do that, when I take the square root of 25, because we picked a perfect square, the square root goes away and the number changes. In this case, just 5, right? No square root left. The number got a whole bunch smaller, right? And then just bring down that square root of 2. That's it. So it's really just 2 steps. Break it apart, simplify the first one. So it's not a super complicated thing, but once we kind of get it going with quadratic formula, you'll see it's kind of side work that we'll do that will allow us to just simplify things just a little bit further. Okay, just a little bit. All right, I don't know, maybe just one more with me. I'm good. I want to pick one where something happens that we want to kind of be careful of. So what if it was like the square root of 32? Right, as always, first thing I'm gonna do, plug it in case I don't know. Plug it in, see if it's nice. If it's nice, boom, I'm done. I don't have to worry about it. Kind of like some of those examples that we've done, right? That square root is perfect, then I can keep going. So I try it, right? Square root of 32, I plug it in, I get 5 point blah, 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 goes on forever. So I know I can't use that number, but I would love to see if there's a way to break this apart into perfect squares for the first one and whatever's left for the second one. So think about it. What number goes in evenly into 32 that's on that list of perfect squares?
16.
16. And that's definitely the biggest one, right? Because that's half of 32. Is there another perfect square that goes evenly into 32?
4.
4. Now watch what happens. Don't write this down, but like watch what happens if we do the 4 instead. Like if you don't pick the biggest one, you pick something smaller than that. What's left underneath this square root if we take the 32 and divide it by 4? What is 32 divided by 4?
8.
And look at that one. That one on its own was the first one that we did, right? Which means I could have simplified this one all by itself, and I would have to do this process twice. Like, watch this. Like, don't write this, but check this out. Like, 2 square root of 8. Okay, now I have to split this apart into the square root of 4 and the square root of 2. I'd have to bring this 2 down. And now I've got all of this all connected. 2 times 2 times the square root of 2. Okay, 4 root 2, right? 1, 2, 3, 4, 5 steps instead of 2. This, although it works, is way more work than it should have been. If we had picked that first one, like you said, if we had just picked 16, right? 16 times 2 is what gets you to 32. Okay, break it apart. Perfect square one goes first. Not so nice one, whatever's left, goes second. The square root of 16 is 4, right? Change the number, drop the square root, bring down the other piece. I mean, we get there anyway, right? You get to the same answer, but way, way more work if you don't pick the biggest perfect square that goes in case there's more than one. Now, sometimes there's only one, right, with 50. 25 was my only choice for numbers that went in nicely. Right, so you want to kind of be careful to pick that best one. But that's it. That's what I wanted to show you today. A simple idea that really pays big dividends if we know how to use it. Okay? So I didn't want to gloss over that option. Just to make sure you're feeling good with it. Okay, so I'm gonna give you 3. Call it 5, 6, and 7. for you to try right now. So you've got some practice. Again, you don't have to submit this, but this will be a really good guide for you when you get to your work for tomorrow. Okay. All right, cool. So let's go like, I don't know, I'm trying to pick some nice ones. Let's go square root of 18. Oh, love that. Square root of 18. I don't know, like square root of, let's say 40. It's a pretty good one. And then, how about 200? There we go. All right, so just try those three. I'll give you a chance to try them out. I'll put some answers up so you can check them, and then you're good to go. A nice short day for you today. A little bit of practice coming at you tomorrow, and then we'll put it together on Monday. We'll probably have to start backing up a little bit to factoring. I'll teach you that maybe Tuesday. And then we'll be ready to start reviewing and getting ready. And so what I'm hoping to do is, fingers crossed, I hope we get back on the 8th hybrid, and we'll be able to do some stuff in person then. But we won't know that until next Tuesday. So we'll see what happens. Fingers crossed, and we'll kind of go from there. So try these out. Let me know if you have any questions. Square root of 18, square root of 40, and square root of 200. Okay, and if you don't know like how to break these numbers apart, use a calculator. Right, divide by some perfect squares, and see which, start with the biggest ones that are just smaller. Right, I'm not going to divide 18 by 400. I'm looking for numbers smaller. I want to break these up into smaller numbers. So look at your list, see what goes in nicely, break it apart. Biggest perfect square and what's left. Biggest perfect square and what's left. Biggest perfect square. Left. Okay, so in a minute, I'll put up some solutions. Check them out. Make sure you're feeling good. And then you're good to go. There you go. Check them out when you're ready. There's all three of them. And I'm good if you're good. Keep it short and sweet for you today. A little practice with this tomorrow, and then I will see you on Monday. And let me know if you have questions. Stick around or ask them right now. Something like number 7, maybe you tried 25, but you'd have to do this, right? You'd have to do it twice, and that would just be miserable. So always look for that biggest one that goes in nicely. All right, catch you guys tomorrow. Yeah, see ya.
Bye, Rosie.
Adios.
I'm done. Bye, Rosie.
All right, see ya. Thanks.
Bye, Rosie.
Later, Johnny. See you, bud.